All right, welcome to the first day of learning about quadratic equations.
Sarcastic, yay!
Why sarcastic? Quadratics are fun. Don't believe me, we'll find out. Okay, we're gonna start off with a homework review.
I will put the link in the chat in like 2 seconds once I get there.
Okay,
Surprisingly enough, these were the 3 questions I got wrong on that.
that makes sense.
This is my only question I got wrong.
Okay, so it says a number x is 2 times larger than its reciprocal. What is the value of x minus 1 over x squared? So a number x is 2 times larger than its reciprocal. The reciprocal of x is just 1 over x. And so x is 2 times larger than its reciprocal. So x just equals 2 times 1 over x.
So realistically, 2 times 1 over 2 times 1.
And then if x equals 2. Okay, wait, first of all, did anyone manage to solve this question? Like,
No, I forgot what a reciprocal was. So, yeah.
For example, like the reciprocal of like x is 1 over x.
Like, I get it now, but like when I was doing the homework, I forgot what a reciprocal was. So I'm just sitting there going like, what in the absolute world is a reciprocal? And since I didn't want to waste time reading what a reciprocal
I was able to solve it.
all right. Do you want to tell us, like, explain the problem to us?
I'm not. I was referring to slides that time, but I believe x was 4, and then so like 2 times 1/4 became 2/4, which is half. Number D.
Right. How'd you find x?
I was referring to the top thing, the x minus 1 over x squared. So 4 would work for that, since a number is also the x is 2 times the reciprocal too.
Oh, so you just like did trial and error.
Yeah.
Okay, that's always a strategy.
I didn't think I'd had time to do trial and error, but I didn't realize how small it was going to be. So now I'm just sitting there like, you idiot, you absolute idiot.
I also knew it could not be over 1 because two, like let's say if it was 3, then 2 times 1 over 3 would be 2 over 3, which is again less than 1. So like the rest 3 answers were all over 1.
Okay, so this one I think covers some stuff that we didn't actually go over in the class. So we're just going to probably just explain the ones that we did do, because I think those will make more sense to you guys. But I like the discussion that you guys came up with about that. So this one says, which of the following is the greatest factorial with only 3 digits?
It's 6 factorial.
All right, so we have an answer. Let's calculate all of them, because why not? So 5 factorial would be 5 times 4 times 3 times 2 times 1, which equals 120. All right, hopefully you guys remember that from last class. And then 6 factorial is 720. What would 7 factorial be? It would be 5040. So yeah, you can see that that's 4 digits, which is more than 3 digits. So whoever said 6 factorial would be correct. And then 4 factorial is 24. So good job.
I actually got it right.
That's great. Okay, Kayang, have you looked at the next one? Is that something we've covered?
This one, I mean, I don't remember if we covered it, did we?
The answer would be B, number 3.
Yeah.
Like 3. The answer would be 3.
Yeah, I know it's 3, but like, I don't remember if we went over the strategy. I don't think we did these algebra ones.
I don't know. I don't remember what the X like. I don't know what the X with the some. With
Oh,
the,
those are factorials. I think we only like went over what it was and we didn't do problems with it.
yeah.
Mhm.
You told us like X minus like a number X minus 1 over X minus, I think it was like 10 factorial minus 1 over 10 is equal to like 10 factorial, I think.
All right, well, a strategy you can use for this one is to just plug in all of the answers for X and see if they work. Since we didn't teach like another strategy. So yeah, that would be the correct answer, 3, right? 6 times
Yeah, it is 3.
4 factorial. Yeah, so that would be the correct answer, 6 times 24. Okay, so let's go back to the slides. So today we're going to talk about what quadratics are. Okay, do you want to talk over this part?
Oh, okay, sure. So, well, today we're gonna do like basically like the basics that will prepare us for like next week and the week after that. So today we're just gonna do definitions of quadratics and then some basic things about what to do with them. And we're gonna graph them using like Desmos and stuff. And then we'll do a little bit of finding factors.
I got a quick question.
Mhm.
What are the 2 days we don't have Mathema class?
So that's gonna be not next week, but the week after that, the 26th. And then the week after that, which is the 2nd of January. So we will take like 2 weeks break and then we'll be back.
So like after quadratics, we'll take a 2-week break.
Wait, so if quadratics is 3 weeks, I think we'll like resume after break. Is that right, Yolanda?
Oh wait. Oh, yeah. Is quadratics 3 weeks?
I
Yeah,
thought it was.
quadratics is 3 weeks.
Yeah, so then,
Okay, thank you.
yeah.
Yeah.
Okay. Okay, so first off, what is a quadratic? So a quadratic equation is just where the greatest exponent in any of the terms is a square. And it can have any coefficient. So for example, a quadratic equation might be like x squared plus 3x plus 4 equals 0, because it's an equation. And quad, in this case, actually means that we have to square the variable. So here you can see some examples. In the is a quadratic list, you can see that all of them, the biggest exponent is 2. So like 3y squared minus 7y, the biggest exponent is a 2. And that's also called the degree of the expression. So the degree is whatever the biggest exponent is. And if it's a quadratic equation, the biggest exponent will be 2. Then direct your attention to the is not a quadratic list. Those, the first one is 3y, which the greatest exponent is just 1. Second one, x squared plus 7x cubed. The greatest exponent is 3. So that would be a cubic function, not a quadratic. And then we have z to the 1/2 and also 8. So those are not quadratic equations. All right, does everyone ask a question right now if you don't understand what a
Yeah,
quadratic.
why would 3y not be an why would 3y not be a quadratic?
Okay, well, 3y, 3y there is just to the first power. So in a quadratic, like I said, the greatest exponent has to be squared. So if it was like 3y squared, then it would be a quadratic.
Oh, that's why every single one on the quadratic list has a 2.
That's right. And we're also going to look at like how these quadratics look on a graph. So when things have a squared term, and that's the biggest term, the shape looks very different from when there's like a cubed term with an exponent of 3 or an exponent of 1. So you'll see in a bit.
Okay.
All right, so just remember the greatest exponent is going to be to the power of 2.
So we'll just go through this and tell me if it is a quadratic or not. So this first one is x squared plus 70x minus 2.
That one's a quadratic because x is squared.
Yeah. So it is a quadratic, and we'll see some more like after this, but this form with the x squared or whatever variable it is squared in the front with the like linear term and the constant after it, this is called standard form. But you'll probably learn about this in school, like different forms of quadratics. We'll focus more on what you can do with it. So okay, next one, negative 40x squared, just by itself. Is that a quadratic? Okay, so I see a few people saying yes, and you're right. So although the only term here is the x squared term, you can kind of think of it as like negative 40x squared plus 0x plus 0, if you want to think about it in that form. So as long as there's a variable with a squared, and that's the biggest one out of everything, then it's a quadratic. Okay, what about 16x plus 4? Yeah, you guys are right. This is not a quadratic. The highest exponent for a variable is 1, so it's a linear. Okay, what about this one? 30x plus 0.55x squared. This one has a 0.55 as the coefficient. So is it still a quadratic?
I wonder.
Oh, I see a few yeses and a few no's. Well, you'll see in just a second, but this is also a quadratic. The coefficient of the like x squared term, it doesn't matter. It's still gonna be a quadratic in a parabola shape. But you'll see that.
Yep, so this number, the coefficient, which is in front of the variable, it doesn't matter. As long as you have this 2 right here, it's still quadratic.
Okay, negative 300x plus 2. This should be pretty simple. Yeah, so this is not a quadratic, only a linear term. What about this one? Y squared plus 3y cubed plus 8. I see some no's. Are you guys sure I have a y squared?
You mean cube?
Yeah,
You said
so
y squared, it's y cubed.
I know, but I do have a y squared, so isn't it a quadratic?
But there's a 3. The 2 has to be the highest.
Yeah, you're right. So it's not a quadratic, like you said. So I do have a squared term, but I also have a cube term, which makes it a cubic, not a quadratic.
So good job, you didn't get tricked by Kayan.
Okay, a squared plus 6a plus 3. This is also in standard form. Yeah, you're right. This is a quadratic. And last one, 3y squared minus y minus 1. Yeah, so this is also a quadratic, and this is also in standard form.
All right, good job. Good job, you guys. Now, okay, so we know how to tell which are quadratic equations, and now we're going to talk about what information that equation contains. And we're going to look at some graphs. Okay. So let's look at this together. So up here you can see an equation, y equals a times the quantity of x minus h squared plus k. So that is something called the vertex form of a quadratic, but don't worry too much about that right now. So now we're just going to see what changing each of these variables does to the quadratic. So first, we're going to change what a equals. And so here's negative 5a, and then this is positive 5a. So what do you guys notice changed?
It flipped over the direction.
Yeah,
It went from up to down.
and when it's up, a is positive. When a is negative, it is down. And then if it's 0, it's a straight line, but we don't need to worry about that. So that's good. And now on to h. So
It
what do you-
changes where the origin is on the x-axis.
So we're going to call this point down here the vertex.
Yeah,
Of,
so it changes the
quadratic.
vertex on the x-axis.
Yeah, so this affects the x coordinate of the vertex. And notice that as h goes positive, it goes that way, negative goes this way. Okay, now finally for k. Does anyone have a prediction for what k will do?
It'll go up or down.
All right, up or down, you say. And yeah, that's correct. So the y coordinate of the vertex changes. The y coordinate of this point goes up or down, and the whole graph shifts as well. Okay, and then one more thing to note. So h comma k is just the coordinates of the vertex. So right now h would be 0.6, k is 2.6. Right, I think someone else from this class joined.
Also, I don't know if you already said this, but notice that like our vertex is h comma k, but in the equation it's like minus h. So if I have like y equals the quantity of x minus 3 squared plus 1, then the vertex isn't negative 3, 1. It's actually just 3, 1. So that's like really easy to miss, and you'll get the hang of it, but it's just something to keep in mind.
Yeah, so h is positive here, but it'll look like it's negative in the equation because there's a minus. Okay. Let me just assign this kid to our breakout room. Okay, cool. And if you want to go back to play around with that Desmos some more, it'll be in the slides, which will be posted to Google Classroom. So here's some other things we noticed. That coefficient a at the start, if a gets bigger, the graph will get thinner. And then if it's smaller, if it was a fraction, it would get like really wide. And then also if a is negative, the graph will open downward. If it's positive, the graph opens up. H is the x coordinate of the vertex and k is the y coordinate of the vertex. So let's use that knowledge. Let me just write out the equation on here to help you. So y equals a times x minus h squared plus k. And remember the vertex is h comma k. So let's look at that equation down here. And can any of you find where the vertex is? Be
Remember
careful.
what I said about the negative h?
It's 3,7.
Nice.
Yeah, excellent job. So you have x minus h is x minus 3. So h is positive 3. Good job. And then you found k was this 7, the constant term at the back. Good job. All right, now even trickier. Is this graph wider than x squared? All right, I'll let you guys answer. If no one figures it out, then I'll give you guys a hint.
What
If you
does that
don't-
mean?
So like, let's say like x
So this
squared.
looks like skinny, and then if it got wider, it might look like this.
Oh. So then what do you mean is the graph wider than x squared? What's x squared?
So x squared is like, it's called the parent function, and it's like you can think of it as the original default for quadratics. And it's gonna look like this.
We can go to Desmos and see.
Yeah.
1 second. I probably should never erase that. Okay. So if we just get rid of this, y equals x squared. So that's what y equals x squared looks like. And then let's try changing. If you change a, you change the width or the narrowness of the graph. So
Okay.
if we do this, y equals 2x squared, then did it get wider or skinnier?
Wider. No, skinnier, skinnier.
Yeah, skinnier because it's the blue one. So good job. And then if we do y equals 1/2 x squared, what happens?
It's much wider.
Mhm. And you can do like something ridiculous like this too. And then see, it's
That's
still going
very
up.
skinny.
Super,
I mean wide, wide.
super fat.
And
Super
also-
obese.
Just a note, if we make this negative, so we're changing the y equals 1/2 x squared to y equals negative 1/2 squared x squared, it flips over and starts pointing down.
Okay. You could go. Okay, thanks.
So if we go back to this one, we can see that a here is going to be 2.
It's gonna be skinnier.
Yeah.
Yeah, good job. It will be skinnier.
Okay, so just like a little summary for you to see. When we write it in this form, it's called the vertex form, where it's like y equals a times x minus h squared plus k. As the absolute value of a increases. So that just means like as a gets really big, like positive big, or really big negative, like 10 or negative 10, then the width of the graph decreases, so it gets skinnier. And vice versa. If it gets smaller, like really small positively, really small negatively, then it's gonna like become wider. And if a is positive, the graph opens up going this way. Otherwise, if it's negative, it goes down. And yeah, it's called vertex form. You'll learn about these forms in class one day. So let's do this. Describe the graph. So tell me what the vertex is, like 0, 0, like that. And then how wide the graph is compared to x squared. And if the graph opens up or down. So if anybody is like willing to unmute and explain to me like the 3 different things per graph, that would be really nice. I'll give you like, I'll give you 3 points if you get all 3 right.
I can explain it.
Okay.
So the three means how if it goes up or down. Like that's part of the vertex. And the one tells how if it's how horizontal it is. Like if it's in like -7 on the graph, so it goes sideways. And the 3 means it goes up 3,
Mhm.
right?
Yeah.
And the x means if the x I believe is if it's facing north, like if it's facing upwards, or if it's facing down.
That's actually the A, and right now you can't really see the A because it's a 1. So you're close. So, but what is the vertex? Like the point?
1, 3.
You're right. Okay, so is it skinny or wide compared to our parent function?
Wide.
Actually, it's the same. So that's also an option because the A
That's
is
why
1.
I just took a random guess. Because
Yeah, I
I thought
did.
it was
So, but yeah, if the A is 1, then it's just the same width as our parent function. Okay, so does the graph open up or down if my A is 1?
it would be up.
Yeah, it's positive, so it's up. Okay, great job. That's really good.
Thanks.
So next person, who wants to try this one?
I could.
You want to do it again?
Sure.
Okay, wait, does anybody else want to before you go?
I'll give it a try.
Okay, so go ahead, Colin. So let's first figure out the vertex. So look at the top left, Yolanda wrote the vertex form for us. So the vertex is H, K. So what is a vertex?
This one's a little bit tricky.
I'm not sure.
Okay, tell me what K is. So the K is the last number at the end.
+4 or -2?
Yeah, it's -2. That's
Yeah,
K.
-2.
And then H is not 4. You have to find the opposite of it, like make it negative. So,
-4?
yeah.
So it's -4.
Oh, that's a horrible K.
so yeah, it is -4 too. Okay, now let's see if it's wider or skinnier. So we said that if the A at the front, which is 3 right now, if it's like bigger than 3, then it gets skinnier. I mean, bigger than 1, it gets skinnier. If it's smaller than 1, it gets wider. So is it smaller, like skinnier, or wider?
I think. I think it's wider.
So it's actually skinnier.
No,
because,
wait, no.
so bigger than 1 is
Oh
skinny.
yeah. Oh yeah, I messed up. I messed
yeah,
up.
yeah.
Oh,
That's okay.
I thought the bigger was wider. Oh.
Yeah, that's what most people seem to think, like, because
Yeah.
you know, it's just our instinct, but it's actually the
Yeah.
opposite of it.
Yeah, that's kind of yeah. I gotta watch out for that in the future.
Yeah. Okay, last one. You can do this one. Does the graph open up or down? If A is negative, it opens down. If it's positive, it opens up.
So it would open down.
So are you sure if it's is 3 positive or negative?
3 is positive. Then it would open up. Yeah.
Yeah, right. You got it. Good job. So yeah, this graph is thinner than x squared. It opens up and our vertex is at -4, -2.
All right, so
Okay.
just to like give the vertex a little bit more explanation. So we know that K has to be negative. Oh, sorry. We know that H has to be -4 because this right here turned into plus. And so our original thing was x minus h. So you have x minus -4. And then if you have two minuses, it turns into a plus. So that turned into x plus 4.
Okay, who wants to try the next one?
I could.
Was that Aniket?
Yeah.
Okay, so nobody else wants to try? I'm sure some of you guys could do it.
It's easy.
It is fairly simple. Okay, then I guess Aniket can get 3 more points. So
Okay.
go ahead, tell us.
The vertex form would be 9, 6. No, 9, -6.
Yeah.
So, and it would be down because A is -2, so it's a negative
Mhm.
number. And it would be, now this is the hard part. It would be wider,
Are you sure?
skinnier than X.
Why is it skinny?
Because I don't know.
Uh-oh. Okay, so I think this is the
Because it
hardest.
hasn't ate much in a while.
Yeah, good answer.
Okay, so if A, like the absolute value rate, so don't think about if it's positive or negative for this. If it's bigger than 1, then it's a little wider. I mean,
Okay.
it's a little skinnier. What am I saying?
So the
Okay, if it's
absolute
bigger than
value.
1, it's a little skinnier. If
It's
it's
the absolute values too. Okay, so that's more than 1.
yeah, so then it's skinnier.
My instinct keeps telling me that bigger is wider, smaller is skinnier.
Yeah, that's like why it's hard.
Can I try the next one?
Yes.
Ooh, okay. So, my oh shoot, I just got a paper cut. So K would be 5.
Yeah. K is
H would be 3.
yay.
Y would be -1/6.
So, okay, you're right. The vertex is 3, 5. Good job. So let's start with if it opens up or down. I think that's a little easier.
Okay.
Positive up, negative down.
Positive. I'm pretty sure it'd open down.
Yes, you're right. Since it's -1/6, it opens down. Okay, last one. This is the hardest part, but it's actually not that hard when you think about it. So if the A, not thinking about the sign, so don't think about the sign, just think about the 1/6. If it's smaller than 1, then it's wider. If it's bigger than 1, it's skinnier. So is 1/6 smaller than 1 or bigger than 1?
I think -1/6 would make it smaller than 1.
Okay, so is it wider or thinner?
It would be wider.
Yeah, good job. Yay,
Yay,
you got it.
excellent.
Good job. Thank you for stepping up and doing this. So,
But I do number 5.
you want to do number 5? Sure.
It would be negative. The vertex would be -2, -4.
Mm-hmm.
And since 1/8 is positive, it would be opening up.
Yep.
And absolute value of 1/8 is 1/8, which is smaller than 1, so that'd be wider.
Correct. That was a great explanation. And I think there's a little typo there. So, but you're right. It's not negative. It's -4, not 4. So,
Thank you.
okay. Anybody else other than Colin and Aniket want to try the last one?
Wait, does that mean
Sure.
Who was that?
Rishi.
Oh, okay, you can try it, Rishi.
Yeah, sure. Okay. So, number 6, right?
Yes.
So -2. I mean -1/2, and then in parentheses x plus 8, and then exponent 2 -4. Okay. So, um, so like I'm kind of confused, like of what to do.
Okay, that's fine. So let's try to go through this together.
Okay.
So let's first try the graph opening up or down one. I think that's the most simple one. So
Okay.
A is a number that's at the very, very front, in front of the parentheses. So right now A is -1/2.
Oh, okay. Yeah, okay.
And
Then in parentheses, like it says x minus h, which is x plus 8.
yeah, so it does say x
Yes.
plus 8 in there.
Okay, and then okay, exponent. Okay, so then the vertex form. So like, no, like, what's the question?
So the question is, there's 3 parts to it, and it's at the bottom. State the vertex, how wide the graph is compared to x squared, and if the graph opens up or down. So let's start with the vertex then. So what would be the vertex?
The vertex would be 4.
You're kind of close. You're looking at the right numbers, but the vertex is like an actual point on the coordinate plane. So it's gonna be like h comma k, like 3 comma 4, something like that.
So like -4.
So that's k, yeah. And then h, if you look at the top, there's the vertex form. H is the number that's after x, but you have to make it like negative.
So it would be 8 over. 8. 8, and then 8's exponent would be 2.
So, well, somebody in the chat is telling you the right answer, but basically h is a number after x. So what number is after x in number 6?
Plus 8.
Yeah.
I mean, plus 8. Yeah.
And then
Positive 8. Yeah.
now you have to reverse the sign. So if it's plus 8, if you
Minus
reverse the
8.
sign, what does it become?
-8.
Yeah. So
Negative.
it's -8 comma -4.
Oh, okay. Well, I mean, for me, no, like I came like a little bit late, so like I didn't know what to do.
Oh yeah, that's fine.
Yeah.
Okay, now let's do how wide the graph is compared to x squared. So if the number a, like not thinking about the sign, so just 1/2, if 1/2 is smaller than 1, then it's wider. If it's bigger, then it's skinnier. So is 1/2 smaller or bigger than 1?
No, like whole, like one whole.
Yeah, just 1, like 1/2, and
It's
then
smaller.
yeah, it's smaller.
Yes.
So is it skinnier or wider?
So you said no, like if 1/2 is bigger than 1, then what is it?
Then it's skinnier.
Okay, so it's wider.
Yes, you're right. It's wider. Okay, last part. I think this is easiest.
Okay.
Does the graph open up or down? So if A, which is -1/2 right now, if it's negative, then it opens down. If it's positive, it opens up.
Down.
Yep, you're right. Good job. So yeah, this has a vertex of -8 comma -4. It's wider and it opens down. So thank you guys for participating.
Wait 1 second. Could you go back to the last slide?
Yes.
1 second.
So for the number in the parentheses, you flip the sign, and for the number not in the parentheses, you keep the sign the same.
Yes, exactly.
Okay, so parentheses flip, no flip. Okay, thanks.
That was a good question.
Yeah. So next concept. If you remember the Desmos, some of the graphs have spots where they touch the x-axis, and those, the spots where they touch the x-axis have a couple of different names. You can call them roots, x-intercepts, or zeros. So we're just going to call them roots for now. And Using our quadratic equation, we're going to teach you how to figure out where those roots occur. So let's look at a Desmos graph. This equation is going to be in a different form. This is called factored form. So it's a little bit different. And so let's again see how changing each of these changes this. So right now we have this graph. Its vertex is 3, -4. And then the two roots or x-intercepts, the place where it touches the x-axis, they are 1, 0 and 5, 0. So let's see what happens if we change a. So let's say we set a to -3. And now the roots change to 1, 0. That one's the same, but this one is now -3, 0. And remember, a is -3. So you
It
can,
changes the location on the x-axis.
yeah, so a affects one of the roots.
And the farther negative or positive you go, the deeper it goes.
Mhm. Yeah, so basically whatever a is going to be the x coordinate of one of the roots. And then, okay, b, we're gonna change b now. So as you can see, one of the x-intercepts is staying in place, and then the other one is moving around.
Also, B affects A and C.
I wouldn't say it like that. I would say b just affects, b controls the other x-intercept. So right now b is 0, and this x-intercept is at 0,
So
0.
A and B have the exact same job.
Yeah, you can say that. So, and then if you change b to 2, then the x-intercept is 2, 0.
So then when you move the C, so like when you move C, then the A and B will move, right?
Well, we'll see. Does anyone else want to put forth what they think will happen?
I think C will make the C point go down on the y-axis.
All right, does anyone else have thoughts or guesses?
I think C will C will make the C point move down, making the maybe changing the angle a bit.
For me, like I think like the C point, like will so like when you move it, like the C point, like will be go up and down. I think
Okay, so let's see.
Yeah, you're right.
it does go up and down.
So actually, whenever you move one of these, like if I move A, B and C stay the same. If I move C, A and B stay the same. So they don't affect each other like necessarily. Since right now, like when she was moving, like it looks different, but it's actually staying the same.
So it seems like the more negative value C is, the more higher the butt goes, and the more positive it is, the more down it goes.
Yeah.
That's like again flipped over.
All right, so and then just remember these have x minus a and x minus b. So again, you're going to have to make sure you don't get the signs wrong, and you'll have to like kind of flip it. So let's see, x minus 2 times x minus 3. And so a right here is 2 and b right here is 3. So that means that it's going to have one root at 2, 0 and one root at 3, 0. So that's like a, 0, b, 0. And so if you have a quadratic in this factored form, then you can easily figure out where it's going to intercept the x-axis. So let's go back and try and get some practice with this. I think we pretty much talked over all of these. And also, so there are some equations all of the ones that we just looked at, I think, had 2 roots. Some equations can have 1 root, which is where, like, say the x-axis is here and it just touches the x-axis at 1 point. Then you can also have equations with 0 roots, which is where they're just like floating up above. I'll draw it right now. It can look like this. So it'll never cross the x-axis. Yeah, and then the coefficient changes the width of the graph. Okay.
So just another like review thing. So in the first form, like the one where we just looked at with the roots, A and B are the roots. And then on the first, like the one we looked at in the beginning, the vertex form, A0 is the vertex and the only root of the graph. So when the K is like nothing or 0, then A comma 0 is the vertex and the root. So it's like the same thing. And like that was called the intercept form, but like you don't really need to know that right now. So for this, I don't think we're gonna do everything it tells us to do. We're only gonna look at the roots because we already did like being wide and opening up and down, blah, blah, blah. So tell me the roots.
It's 2 and x.
Is
Or
x a root?
Oh no, 2 and nothing. It has
No.
just one root.
Okay, so this one is pretty confusing. So true is right, but the one that says x, isn't it the same thing as x minus 0?
Yeah. Oh yeah, that makes sense.
So it's actually 0. And you'll learn more about like all of this later. So
That was a trick question.
like the way you're actually supposed to solve this is to set each of them equal to 0 and one of them becomes 0 and everything will become 0. But I think that's a little too much to learn at once. So right now we're just gonna think about it like x minus 0. Okay, let's do the next one.
Oops.
Okay, 3 times x plus 5 times x plus 3. What are my roots?
I know.
Okay, Colin, you say one, and then Anika, you can say the other one.
3.
5.
Okay, so both of you guys are really close, but we have run into the tricky signs again. So
Oh, it's -5 and -3.
yeah,
Why do we always have to flip the signs? That makes no sense.
yeah, math can be confusing. Quadratics does a lot of like flipping sign stuff, so you just kind of have to know those. Kind of just memorize it, and once you start working with these in class, you'll just like know it. It'll be second nature.
I do the third one.
Okay, you can try this one.
It's 9 and -3.
9 and what?
9 and -3.
Oh,
Yeah,
well, I was gonna say if I could do it.
you can do 4.
Okay. I think this is -10 and 6.
Yeah, good job. Okay, so I think this is more simple. 2 other people other than Colin and Aniket tell me, what's number 5? One of you. I'm sure some of you guys are just like watching and not saying anything.
If nobody says, can I say it?
Yeah,
It's -2 and -4.
yeah, you're right.
Ying is just waiting for an unexpected genius to pop up.
I'm gonna pick on somebody for the last one.
Pick on
Can I do it?
pick on Anushka. Pick on Anushka.
I'm gonna pick on,
Can I do it?
who was that, Rishi?
Yeah.
Okay, yeah, you can do it.
Okay, so y equals c, and then state the roots. How wide the graph is compared to x2, and if the
Just
graph,
do the roots.
yeah, the roots. Okay, the roots are -10, and then -10, and then +8.
So one of them is right. For both of them, you have to flip the sign. So
Yeah. Okay. Yeah. +10 and then +8.
good job. Yeah, that was right. Okay, if we have another one like this, I'm picking on somebody new.
Okay. Well, now we're going to go to a Desmos. But there's still questions you can pick on people in the Desmos.
Okay.
So let's see, where is it?
Oh, it's in the like speaker notes. Wait.
Okay, I found the link.
Oh,
I
okay.
will put it in the chat. So go ahead and join the Desmos. So we're just going to be going over more about how these quadratic equations look on the graph.
Also, Yolanda, do you have access to it? Oh, okay. Yeah, because I don't.
Oh, you don't? Oh, wait, let me share it with you. What's your,
I have access to it.
wait, maybe I can just.
I'll private message you my email.
Okay.
I'm for sure you've seen it like a million
I
times.
just don't know what all the numbers mean.
Oh, okay, yeah.
Oh, wait, but then it's going to show up here anyway. Okay, and let me stop sharing for a second.
To the math teacher, you're supposed to deal with numbers.
Yeah, Yolanda. Why don't you know my email?
Wait, if there's, are you still in like college or high school? Are you still in college or where are you?
Guess how old we are. Get it right, I'll give you a point.
Okay. Yes. About your
23.
around 25.
20.
23. 23.
I'm just kidding. I'm just kidding. I'm just kidding.
18.
Okay, thank goodness.
20?
I was about to be like,
18.
all right,
16 or 18, something like that.
20 to 23, 20 to 23, 21, 22.
Okay, I'm
Really?
not 16.
yeah.
17.
We're not-
18.
Yolanda, how old are you? Can you?
19, 20, 21, 22,
Three.
23, 24, 25, 26, 27, 28, 29, 30.
Stop giving us a
Okay.
break, Rishi.
You guys can definitely not be 30.
I am
What if?
so close to being 30.
I am 40.
Really? No way. No way. No way. You are lying. You are not lying. You are literally lying.
I'm not a 5.
You are actually lying. You are not close
Okay,
to 30.
I'm close to being 20.
Okay, 19.
19, 19.
18, 18, 19, 18.
Okay, I lied. I'm
You
not
guys
close
think
to
we're
being 20.
old. Okay, let's
You are
get,
17. I'm
let's get
confident.
to this.
17.
Okay. I don't think anybody has gotten it except for one person in the chat, but
Yeah, one
Anyway,
I
person
know who you
got
are
it.
and you're cheating because of your brother. So that does not
The
count.
reason I said it is because technically they're
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14,
Whatever.
15, 16, 17, 18, 19, 20, 21, 22, 23.
I'm one of those.
You're 18.
You think I'm like legal?
What?
I'm
do you
Okay,
not-
okay, guys, let's focus on math here. We need to plot a parabola through these
But
points.
it's fun.
One day,
a minute.
let's do Mathema reading. I mean,
reading.
Oh, it's called Mathema, not Readema.
reading them.
Reading. I don't think that's a good name.
Okay, so we need to plot a parabola through these points, and we're going to use vertex form. So one easy way to do this, oh wait, so where's the vertex of this graph?
0, 0.
0, yeah, 0, 0, yeah.
Yep, that's right. So we don't need to know a right now, because if we get it wrong, we can just change a around. And so it would just be x minus 0 squared plus 0. Okay, let me erase my horrible drawing. And you can see, wow, that exactly fit all of the points.
First stonks be like.
So technically, we don't have to write the zeros. It could just be simpler, like x squared. And then technically a is 1. So just remember that. And that is the correct answer for this one. Okay, everyone on the Desmos, go to the third slide.
The chat is spammed with the age guessing. I can't even find the link anymore.
Oh,
I'll resend. Okay, this is Anara Boom. That's the code. You can just tell me how old I am.
no,
18
Aniket said you're
slash
18, now
19.
you have to be 18.
Yeah, I think so.
Okay, so we need to plot parabolas through these color coordinated points. So first, someone tell me where the vertex of the blue parabola is. So that one would look,
The vertex is.
I know it's -4, 0.
oops, like this.
You said purple.
Oh, no, I said blue.
Then
Oh.
it's 3, 0. No, it's 0, 3.
Could somebody explain what the vertex of a parabola is again?
So the vertex is like the, I guess like the tip or where the two curved parts meet. It's
Yeah.
either the topmost or the bottommost.
So these are the vertexes. So we're gonna focus on the blue one. And
They
the
all look
blue
like
one,
bears.
The vertex is 0, 3.
yeah, that is
That one's
correct.
gotta be negative
0, 3.
0, 4.
And now we can use this to figure out what the equation is. So just as a challenge, does anyone know the equation of the blue one right now?
Yeah,
At
I
this
do.
right, I'll give you 2 points.
Can you go back to slide number 2 real quick?
Oh, you can go back on your own, right?
No, but
Oh,
I
you-
want to see it on your screen.
Okay.
Are you cheating right now?
No?
I'm kidding.
Okay, I got it then.
Dun dun dun.
Okay.
It has to be y equals x in one parentheses and in another parentheses 4, net minus 4, x minus 4, or x plus 4. No, in another parentheses, x plus 4.
All right, that's a good guess. That is a good
Wait,
idea.
which one are we trying to do?
We're trying to do the blue one. So
Okay, yeah,
let's
skip
first we'll go back on this vertex and remember I'll write the equation up here again. So
Wait,
it is
Yolanda, check the
A-
chat.
Oh, is it? Oh, did someone put the answer in the chat?
Maybe.
Okay,
Yeah.
let's
I did.
try that one. X plus 0 squared plus 3. All right, so how do we do? Did we get it? Let me erase
Yep.
everything so we can tell.
Yep.
Yes, we did. Good job.
You get 2
Um,
points.
So what's
I was testing things out and I matched the points, but it was x in parentheses x plus 3. So x and then parentheses x parentheses plus 3.
like this?
like that?
X squared plus 3.
I literally didn't even put a square.
Wait. Oh.
Wait, that's not possible because then if
Wait,
it's just X plus 3
erase all of it. Or erase all of it. So I did x and parentheses x
Oh,
parentheses plus 3
yeah. So you just did X times X, and X times X equals X squared. So you did the same thing.
plus 3. Okay.
Yeah. So
Good
that also
point.
works. Although we should try to do it in vertex form to make it easier.
Okay,
So
do I
you
get
can see that 3 equals, first let's finish writing this. So vertex form is x minus h squared plus k. And the vertex is just h comma k. So you
Okay.
can plug the values of the vertex into this equation, and then you get the equation of the quadratic.
I got the equation for purple.
Oh, what did you get?
Oh,
In parentheses, x plus 4 squared plus 0.
Yes, do I equals.
Oh, my bad.
Wait, what?
You
What?
gotta click
Oh,
on
that's-
check my work.
But the blue one popped up. Okay. Oh,
Oh, huh, okay.
okay, good job. Yep. So let's go back and find the vertex. So Aniket, what was the vertex of the purple one?
It was minus 4, 0.
Yep. So then you plug the, what you did was you plugged this in to this equation. And then that's how you found the equation, correct?
Yep.
Yeah.
can
so-
you just like flip the symbols and it'll be like the one for green?
Well, let's see. Let's test that theory. Okay.
Which specific signs do you mean? It is flipping some sign.
It is flipping the
Like,
1 in the parentheses.
Turn the 4 into a -4.
Yeah.
Like -4.
Wait, who's talking? Who is 2158KY? Yes.
Oh, Sharon.
Oh, okay.
And I know it for the yellow or the orange.
All right, let's slow down a bit. Okay, you can do the yellow thing after, but let's just go through this. So that is correct. And let's just go over how to get from the vertex to the equation. So for purple, h was -4. And then when you do x minus h, that's x minus -4, which turns to x plus 4. So you can think of that as just flipping the sign. And then this 0, you don't have to write it if you don't want to, because it doesn't matter. And for green, the vertex is 4, 0. So h is 4, and you just do x minus h. So x minus 4 squared, and then technically there's like a plus 0 after that, but that doesn't matter.
Could I
Okay.
share for yellow or orange?
Yeah, go ahead.
It's the same as the blue, except instead of +3, it's -3.
All right, x squared minus 3. And yeah, that is correct. This is a bit messy, isn't it? All right, I'm just gonna write number, the blue one like this. Yeah,
Okay.
so that is correct. Because, so what was the vertex for the orange one?
0 minus 3.
Yep. And then you just put k, you just put k as plus k at the end.
What's your question, Colin?
My Desmos is broken. When I click on the purple box, it highlights the orange dots. And when I put it and when I wrote something in it, it didn't show anything.
Huh.
Did you click check my work?
No.
Click check your work.
Wait, okay. Wait, so I'm gonna go to. For me, when I go on to blue, it highlights everything. When I go on to green, it highlights blue. When I go on to orange, it highlights green. And when I go on to purple, it highlights yellow.
Oh, it does. Huh, that's interesting.
Hmm.
Well, it does work if you put in all the equations and then click.
Yeah,
check.
it still doesn't check the. It still doesn't put the line when I click check my work.
Maybe we
So
can.
I am going to file a lawsuit on Desmos.
Oh, it's probably because you put a y right here. So change this to an x. Okay, and then change your equation a bit. It just
Okay,
I think you
yeah, I was just putting random stuff.
okay. So yeah.
Oh yeah, okay, now it's up here.
Yeah. Okay. So let's look at 4. Kayang, do you want to take this?
Okay, sure. So
Eric is
Yeah.
correct.
we have two people, Eric and Jenny. So Eric thinks the equation y equals x minus 3 squared will match the blue graph. And Jenny thinks it'll match the red one. Who is correct?
Eric.
Why do you think it's Eric?
Because in the parentheses it says -3, and -3 is the vertex for the blue one. For the red one, it would be +3.
Okay, so you have the right thinking,
Wait,
but
you got
Oh, it's Jenny.
you gotta
it's
flip the
Jenny
sides.
because
Yeah. Yeah, it's Jenny
Yeah.
because you have to flip the
Fine.
sides.
yeah, exactly. So it's actually Jenny.
Yeah, you got it right. Let's go. I was thinking that, but I didn't want to interrupt Anakit. Anakit, I mean, sorry.
All right, let's continue.
So this one, wait, how many more do we have left?
We have a lot. We're not going to get through the whole thing.
So let's see. Wait, hold on 1 second. I want to see what else is there.
Ooh,
Okay, so I looked at the Kahoot, but like I didn't like it. So
so let's just stay on this.
now let's just do this for the rest of class. Okay, and then I'll have a special question at the end, last 5 minutes. So, okay, plot 5 parabolas. Each parabola should pass through the origin and a pair of color coordinated points. One is done for you. So basically what you want to do is make your vertex the origin for everything, because that's like the easiest way to make everything pass through it. And then you're gonna use some trial and error at this stage. So like, for example, let's look at the, let's do the orange one. So the orange one, would you agree with me that it's skinnier than x squared? Yes, I'm gonna assume you agreed with me. So it's skinnier. So that means a, like the absolute value of a, has to be bigger than 1. So I'm just gonna go ahead and try like, I don't know, 1.5. But the points are below the origin. It's opening down like this way. So I know that my a has to be negative. So I'm gonna try negative 1.5 times x squared.
Right. And then check my work.
Okay, so I'm kind of close, but my graph is a little like wider than the one that will go through the points. So now I'm going to increase my a little. So I'm going to make it 2, -2. And yep, a perfect fit. So you're going to go through this process and do the same thing for the purple one and the blue one. So the purple one opens
I know.
down and it's
I know it for blue.
okay, so we're not gonna, how about you guys try to do the purple and the blue on your own, and once you got both of them, you can like raise your hand in the Zoom meeting.
Why won't we do green?
Oh, is there green?
Yeah.
Oh yeah, my chat thing was just covering it. Okay, then do blue, purple, and green. Yolanda, we can like see your screen.
Oh, a problem with that? I mean, I know you can see it, but like, is there a problem? Well, I guess people can see each other's answers.
Yeah.
Okay, we don't want that.
If you get all 3, I'll give you 5 points.
Whoa.
What, did somebody get it?
No, it's just a sine wave.
Whoa, what the heck?
Do you see it?
Oh yeah. You'll learn about that sometime in high school, most likely. Unless you're like insanely smart and you are really fast in the school curriculum. Or you learn outside of class, like school class.
I got it. I got all of them.
You did?
Yep.
Okay, just for the purpose of like, class and people working, I'm gonna wait like 5 more minutes. Or not 5, like 2 more minutes.
Wait, do you have access to the dashboard?
Me?
Hmm. Like I sent you, it should be in your email.
Oh, my email.
Wait, I got a question with the purple.
Go ahead.
It's like it's not like a it's I know the answer, but it's not like 7 or 9. It goes into like deep, it goes into the hundreds place. Is that supposed to happen?
All right. now
Um,
let me stop sharing and then look at your screen.
here, yeah. I have access to the dashboard, but I'm like currently actually doing this thing, so.
Oh, okay.
Should I share my screen or what?
No, because then you'll give it away to everyone else.
Yeah, but that's what I thought Yolanda said.
Oh, I don't know. Okay, mine also goes into the hundreds place, so I think you're fine.
Okay. Should I private message, like private chat you to just to make sure my answers are correct?
Sure.
Okay. I'm gonna go in order, like from blue, green, orange, and purple.
Okay.
I think it's probably just that it's a fraction. Like I got a pretty
Yeah,
standard
probably.
fraction.
Yeah,
and that's
I
probably
also
why
got
it's the
a
decimal.
fraction.
Okay.
Let's see. Are you doing it to Yolanda?
No, I'll do it to Kayung.
Oh, okay, so you haven't done it yet.
Here.
Whoops.
Okay, I see
I'm
the
doing it.
first one. I see the second one.
I sent you all 4.
Okay.
Blue, green, orange, and purple.
Yep, you got everything that I got, like exactly same.
Okay, good.
Yeah. You're really good at this quadratic thing. Have you learned this before?
No.
Oh, really?
Yeah.
Okay, that's cool. So,
Teachers.
All right. So how's everyone else doing? Are you guys a bit confused?
I have more time.
I'm done.
okay. Should we move on, or does anybody want to keep experimenting?
I would like to keep experimenting.
Okay, we will wait for you until 4:26, so you have like 2 minutes. And then after that, if you want to tell us your answer, Jackie, we can do that since I already know it's, and I know it's right. So. Also, Yolanda, can you give me like remote annotating thing?
Oh, yeah. Okay, it should work now. Try it.
How do I like even annotate?
Just press down.
Oh, okay. Yeah, when we are done with this, I have a special question. Okay. How do I like delete?
You have to, okay, stop moving your mouse and then,
I also did challenge 5.
All right, I got all of them.
Oh, okay.
now you're good.
So who wants to share? Colin or
Me,
Jeffrey?
me. No, me.
Okay, so Colin, you can do blue, Anika, you do green, and then Jeffrey, you can do purple. Are you guys okay with that?
Okay. For
Sure.
blue, I got y equals 1/5 x squared. X squared is in parentheses.
Great, that's what I got.
Me
So
too.
Yolanda,
My turn.
Wait, can I
Y
type it?
yeah, you should type
Oh, wait, what did you say for blue?
y equals 1/5 x squared.
Okay,
So for green, I got y equals minus 1 x squared.
Yep. Which is the same thing as minus x, like negative x squared.
So
Okay.
the larger one, minus 1.
You
For
wanna
purple,
tell us?
I got negative 1700 x squared.
Yeah, so like
I think the actual answer is like 1/6, but yeah,
that's like the same thing.
yeah, they're the same.
That's what I got. 0.17. So good job, guys. Okay, now time for my special question that might not be so special.
Okay,
So,
give you remote access.
okay,
Is
so
it,
this is gonna
is
be
it
about,
challenge number 5?
no, it's gonna be about my age. And it's gonna
Ooh.
be the answer to this question. So, I'm gonna give you this y equals negative 6. This might be a little too easy.
Wait, so what is your
Yeah.
age? Is your age X or Y?
I'll tell you. Okay, so my age is one of the roots, and it's one of them that like makes sense to be a human.
Because you can't have a negative a.
So somebody tell me what my age is.
I'm not even gonna solve the problem. I'm confident. It's 18,
But that's not the answer.
16,
Look at the problem.
17.
Look at the problem. What age do you
18.
get when you solve it? What's my age? It's like there's 2 roots, right?
I know it's probably not X minus 50, maybe.
So what are the roots?
X plus 12, negative 12 and positive 50.
Okay,
Yeah.
can I be negative 12 years old?
You're not 50 years old.
Are you sure?
You're
You
not
look
50 years
very
old.
young for
You're-
us.
Positive 69.
So the conclusion is that you will never find out my age. Okay, guys.
Okay.
Exactly.
Well, thank you for
Good
coming
class.
to class. Bye
Good
bye.
class,
Do the
everyone.
homework.
Bye
It's
bye.
Desmos.
What about Kahoot? No Kahoot.
No, good.
Homework?
We have a Desmos for homework, I think.
Everyone hit Alt Q. Alt Q.
Bye, guys.
Bye.
Bye-bye.
Bye.
Thank you for participating
Bye.
today. Bye bye.